we continue our discussion of infinite series. In this video, we look at the p-series test, which is a very powerful consequence of the integral test. In a previous video, we looked at both the infinite series 1 over n and the infinite series 1 over n squared, and we applied the integral test to both of those infinite series. If we were to take the integral test and apply it to the general form 1 over n to the p, we would get the following conclusions. If p is greater than 1, that series would converge. If p is less than or equal to 1, that series would diverge. This is called the p-series test, and it's a very special consequence of the integral test. Let's take a look at two examples, and let's apply the p-series test to determine the convergence or divergence for each of these series. Example A, let's take the infinite series n equals 1 to infinity of 1 over the square root of n. Now our first step is to recognize that this is in fact a p-series. We can rewrite 1 over the square root of n as 1 over n to the 1/2 power. And now we apply the p-series test. How does 1/2 compare to 1? 1/2 is in fact less than 1, so that puts us in the second condition, where our power is less than or equal to 1, and so therefore we say that our series diverges by the p-series test. It's that simple. The series diverges by the p-series test. This is extremely useful. Let's take a look at the second example. This time we have the infinite series n equals 1 to infinity of -2 over n times the square root of n. We're going to look at this and we're going to say, what is this infinite series if I rewrite it? Well, that's the same as -2 over, and what is n times the square root of n? Well, let's see. N is n to the first, square root of n is n to the 1/2, and if I have like bases, I add my exponents. So really, n times the square root of n is just n to the 3/2 or 1.5 power. This again is a p-series test. Now don't let that -2 bother you. Remember, just like if you had an integral, so too if you have an infinite sum, you can pull out a constant multiple. So if it helps you, pull out that -2. What's left over is your p-series, and now this time, our p-value here is actually greater than 1, so that puts us in the top category right here. So if the power is greater than 1, that tells us that the series converges. So therefore, our series converges by the p-series test. The p-series test is an extremely important and useful test, and we will use it in conjunction with other tests later on as we move forward.